I love these summary pages because they get a lot of lessons work onto one page, and they're a bit easier to revise and learn. So summary of preparation of pure dry salts. So we've got three different summary, three different reactions we need to know about, three different methods we need to know about. So the first one is insoluble, where we start with an insoluble reactant and a soluble reactant. It's a bit of a mouthful, isn't it? An insoluble reactant and a soluble reactant. And they make soluble products. So the products are soluble products. Hopefully you can see that I've written that a bit small. Right, an example. Let's give you an example. It's probably easier to see an example. This was the core practical, the one you need to know most about. So copper oxide. Copper oxide is the insoluble, and sulfuric acid. So they are the reactants. Let's give you a simple equation. So CuO, that's the solid, plus sulfuric acid, H2SO4, that's aqueous, that's soluble, makes copper sulfate, aqueous, plus water, H2O, liquid. Okay, so that's the example. So how do we get a pure dry sample of copper sulfate? That's what we're trying to do. Prepare a pure dry sample of salts. So we want to prepare copper sulfate. Right, so there's 4 stages to this. First stage, mix. You're going to mix the and we're going to use an excess, too much copper oxide. So we're going to mix the reactants, copper oxide and the sulfuric acid. So if you want to draw a diagram of that, feel free. Have a beaker there, and we're just going to simply have a stirring rodding. So we're going to stir it as well to ensure it reacts. And we've got our excess copper oxide, and we've got our sulfuric acid in there as well, H2SO4. Once we've mixed it, we want to make sure all the sulfuric acid reacts, so we're going to warm it up. Okay, so to warm it up, we'd put that on a tripod and we would heat it. So that's our warming. After we've done that, we want pure copper sulfate. So to have pure copper sulfate, we've got to get rid of the excess, the too much copper oxide. We do that by filtering. So we can have a filter funnel, filter paper. So our copper oxide, our excess copper oxide is going to be there. And down here is going to be the solution of copper sulfate, because we've made copper sulfate and water now, CuSO4 aqueous. And finally, to get the copper sulfate away from the water, we need to evaporate. And we can have a diagram of that again. We have a tripod, and we're going to heat under the tripod. On top of the tripod, we're going to have an evaporating basin. And that will drive off the water, and we're just going to be left with our copper sulfate crystals. And there's our pure dry sample. Next type of reaction is where all the reactants and products are soluble. Okay, this is a much more difficult method. An example would be sodium hydroxide. Sodium hydroxide is soluble. It's an alkali. It's going to react with hydrochloric acid, which is, again, soluble. It's aqueous. And that's going to make sodium chloride, which is soluble, and water, which is a liquid. I'm just going to put H2O down. And water, which is a liquid. Let's give a simple equation for that. NaOH, aqueous, plus HCl, aqueous, makes sodium chloride, NaCl, aqueous, and water, H2O, liquid. Okay, much more difficult. For this one, we need to titrate. Okay, the most important thing is we titrate, and for titration, we need a burette. Long, thin tube. Okay, tap at the bottom, fill that with acid, and we're going to titrate that against the alkali in the beaker down here. So in here, we're going to have alkali, and it's going to be a measured amount of alkali. I would measure it out using a pipette. Again, a very long, thin tube, a little bit of a bulb in the middle. Okay, and that measured out exactly 25 centimetre cubed alkali. So that's called a pipette. This is called a burette. Okay, and we're going to add some phenolphthalein to that as well. Phenolphthalein. Phenolphthalein is an indicator. Now, when we add an acid to an alkali, we neutralise. So the phenolphthalein will tell us when all the alkali has been used up. At that point, we stop adding the acid. And at that point, we have exact amounts of acid and alkali. So the important point with this one is exact amounts of acid and alkali, and both reactants. We need exactly the same amount of both reactants. Okay, so we do that by titration with phenolphthalein. Titration using phenolphthalein indicator. You can use other indicators. Avoid universal because the colour changes aren't obvious. Titration using phenolphthalein indicator. Once we know that neutralisation point, then repeat without the indicator, okay? And that's important because we want a pure sample of that salt, the sodium chloride. If we stop once we've got phenolphthalein indicator in there, we've got salt and indicator. So once we know that neutralisation point, we're going to do the whole thing again. But we're going to do it without indicator. Now, we won't see the neutralisation point because there's no indicator, but we know it's the neutralisation point because we did it previously. After you've done that, you've got sodium chloride and water, so we want to evaporate. And that's the second one. Last one is where we have soluble reactants, and insoluble, and well, I should say one insoluble product. Okay, an example there would be silver nitrate, and and that reacts with something like sodium chloride. Let's put the word down. Sodium chloride. Now that makes sodium nitrate, which is soluble, and silver chloride, which is not. That's a solid. So it precipitates out. So I'll give you a simple equation, AgNO3 plus NaCl, all soluble. So that's soluble, aqueous. That's soluble, aqueous. That's going to make sodium nitrate, NaNO3. That's soluble, aqueous, plus AgCl, and that is a solid. So we want a pure dry sample of that solid there. Okay, so the way we do that, first off, we mix. Doesn't have to be exact quantities. Just going to mix the silver nitrate and the sodium chloride. Okay, when that happens, we're going to get a soluble product and a solid. So we want to get that solid out, so that's easy. We filter, and that gets that silver chloride out. And you can draw a little diagram now. I'm quite a fan of drawing little diagrams next to these things, no matter how messy they are, because just the act of drawing a diagram helps you remember it. So you're going to have that solid there. That's going to be the solid, and all the product, the silver nitrate solution. Okay, the solutions are going to be down here, and of course there'll be one of these will be in excess, and whichever that is, that will be down here as well. But this will be wet and dirty with, what's the word I'm after? Polluted, I suppose, or contaminated, possibly contaminated is the best, contaminated with sodium nitrate, sodium chloride, silver nitrate, maybe, any of these soluble reactants. So the next thing we have to do is wash it. Okay, so the way we're going to wash that is we just get some distilled water, or deionized water. Distilled water is good because there's no salts in distilled water. So you have a squeezy bottle, and that's just full of water. Okay, you wash it with distilled water. And that just cleans any of those unreacted reactants off, and mainly the sodium nitrate off it. So wash it, and then after you've done that, you're going to dry it. Open the filter paper up and dry it. So mix, filter, wash, dry. That's the important things there. That's square off the important things. That's important. So they're the important things, and you can pick the important ones out of that middle.